So there are multiple applications that we need to understand basically before starting the actual polynomial or actual rational functions. The first thing, that basic skill that we have that will be required to tackle the rational functions concept is the polynomial division. So now when we are dividing, let's say any particular number, let's say we have 8, and if I'm dividing with 3, so what we get is some quotient and we have some remainder. So this is the remainder. So now what we can do is the 8 can be written as 2 times 3 and plus 2. So this 2 that you see is actually the quotient. So this is quotient times like divider, you can say this is the divisor, and plus remainder. So we have got this as a general structure. So if you want to similarly do the same thing for, if you want to do the same thing for the polynomial functions. Now let us say when I'm dividing a polynomial function like 3x squared plus 5x plus 7, and if I want to divide by x plus 2, how do we go ahead about this? Like how do we divide a polynomial function with the other one? Now, generally, this polynomial division is only possible, number one, when degree of numerator, which you see, like the coefficient of the leading term, I mean, not coefficient, the power of the leading term, it should be higher or equal to the denominator one. So let us say now when you have 3x squared plus 5x plus 7, if I want to divide it by x plus 2, so I can write down like this. So 3x squared plus 5x plus 7. And now I'm going to start my division process with when I'm doing with x plus 2. So the first step that we need to be careful about is that here the division process is we start canceling the first number. So first variable number combination, that whatever we have, our objective is to get rid of them. And accordingly, you decide the quotient. Now, here what you see is that x plus 2 I have, and I have the tool that which I will use to cancel this 3x squared is the divider itself. So what quotient out here should I take that gets me 3x squared something? So if I take, let's say 3x out here, now what I do is I first multiply 3x with x, so it'll become 3x squared plus 6x. Now our next step is to actually do the same way where like you're subtracting. So if you subtract, obviously whatever the sign that you have with these numbers, they reverse. So if this was negative, this become positive and vice versa. Here both of them are negative. So what we do is we basically strike out the first number. 3x minus, now 5x is positive, and if I'm, so 5x minus 6x, obviously it'll be negative x, and bring down this 7 as it is. So this is the first step where like you cancel the first number. Now once again our next objective is to strike out this negative x now, and I have x out here. So what I do is if I take quotient as -1, what I'll get is I have to get exact same number, these same variables as this. So what we have got is negative x and -2. If I multiply this -1 with x plus 2, I get is negative x, -2. So this becomes positive, this becomes positive when I subtract them. So it's simple. If I subtract negative x plus 7 minus x minus 2, it's like you're subtracting 8 minus 6. So the same way you're subtracting these two. So what happened is that this become negative x plus 7 plus x plus 2. So that's where this get cancelled. Negative x and positive x get cancelled. And you get 7 plus 2, that's 9. Now, once we get a number or constant number and you're dividing with a factor or a polynomial, you stop there. You can't further divide it. So that's the first example on how to carry on with the polynomial division. Let me take one more example that probably will give better clarity. So now in this case, if I just wanted to write down a similar structure like this, any 3x squared, like if I have got 3x squared plus 5x plus 7 can be written as x plus 2 times 3x minus 1 and plus 9. So quotient times the divider, which is this times this, and plus 9. If you open this up, you'll notice that you're getting the same exact polynomial. So that's the first part. That's the first example. Now let's take the next one. So now our next example is, let us say, if we have got 3x cubed plus 7x squared plus 8x, let's say plus 8, and I don't have any x term. So if I'm dividing 3x cubed plus 7x squared plus 8, let's say with I'm dividing with, let's say, 2x squared plus uh, 5, that's my, let's say, divider. Now, how do I carry on with this process? It'll be really interesting in this case is actually to take care of every single term. Now, even though you don't see a proper x here, we can allot plus 0x plus 8. That makes our life much more easier when you're carrying on the operations. And here also you see that ideally you have a polynomial that you're dividing is like x squared, then x, and then constant term. So what we get is here 2x squared plus 0x and plus 5. So when you're dividing this particular polynomial in this case, what we get is that if I have to cancel out this 3x cubed, my I would take it a little easier one. I would take, instead of x squared, I would, instead of 2x squared, I would take x squared, and in the next example I'll make it a little complex. So here I wanted to strike out the first term, which is 3x cubed, and I already have, I can see that x squared is out here. So I'll start with 3x. Now when I multiply 3x with x squared, it is 3x cubed plus 0 times 3 will be again 0 x squared. 0 times, I mean 3 times 5 is plus 15x. So the advantage of writing these zeros and with the terms which doesn't seem like existing is going to help us to make more systematic calculations. Now here, if you look at, if I subtract, the signs are going to change. So this gets cancelled, and now 7x squared minus x squared, 0x squared obviously is going to be 7x squared itself, and 0 minus 15 is negative 15x, and plus 8. So that's my first step. Next step is to cancel out the 7x squared now. So plus 7 when I do here. So what we get is 7x squared plus 0x basically, and plus 7 5s are 35. And then you subtract once again. So if I subtract, this get cancelled. This negative 15, negative 0 is negative 15x itself. And 8 minus 35 will be basically negative 27. Now this is where we got to stop, because you can see that this power now has become lower than the divisor power. So that's how we look at the polynomial division. And now let us take one more example with a little bit of fraction involvement. So here's the third example on the polynomial division. Let's say I'm dividing 3x cubed minus 7x squared plus 5x plus 2 with 2x plus, let's say, 2x plus 1. Now here it's a little long procedure, but we definitely have the same structure that we follow. So 3x cubed minus 7x squared plus 5x plus 2. And you can see all the terms are there, so no need to allot any 0 or something. And you have divisor at 2x plus 1. Now, what I do is, here you can see I have 3, and the problem here is that we got 2, and then there is no common number that I can straight away multiply with so that I get 3x cubed. So here I'll have to multiply with 3 by 2x squared, because if I multiply 3 by 2x squared, so 3 by 2x squared times 2x, 2 and 2 get cancelled, and I get 3x cubed as the result. So this part is going to be 3x cubed now, and 3 by 2 times 1 will be again 3 by 2 itself, so 3 by 2x squared. And now you do the subtraction process, so minus and minus. So this get cancelled. Now we get is minus 7 minus 3 by 2. So if you don't understand mental calculation, you could just do minus 7 minus 3 by 2. What's that particular answer? So when I take LCM of this, 7 2s are 14, 14 minus 3, I mean minus 14 minus 3 is minus 17 by 2. So that's what is going to be your this term. So minus 17 over 2 x squared 5 by 2, 5x and plus 2 as it is you carry down. Now next job is to strike out this minus 17 by 2. So how do I do that particular case? Now here you can see that you have minus 17 by 2. So I should get minus 17 by 2. So only that I'll get by multiplying by minus 17 by 4x. Because what I look is if I have 2x times minus 17 by 4, this 2 and 2 get cancelled. I get, and obviously there is x. So x times x is x squared you get, and minus 17 by 2. So this part will be minus 17 by 2x squared, and minus 17 by 4 times 1 will be minus 17 by 4x. Now you subtract this, so it will become positive. You can see the sign opposite always you take. This is negative, so it will become positive. This get cancelled, and you get is 5x plus 17 by 4. So 5x plus 17 by 4x, you can add separately and see. So this is 4 5s are 20, 20 plus 17 is 37x over 4. So this part will become 37x over 4 and plus 2. Now we are at the last stage where we have to get 37 by 4x here. And of course, then what we do is we take here 37 by 8 times x, 37 by 8 itself, because 37 by 8 times 2 will be 37 by 4x. Because if I multiply this with this, so let's say 2x times 37 by 8, so 2 and 2 here will be 4. So 37x over 4. So this part will be 37x over 4, and 37 plus 8, this part will be 37 plus 8, I mean times 1, 37 over 8 times 1 is this. Now final step is to obviously subtract. So if I subtract, these two get cancelled, and when I do 2 minus 37 by 4, 37 by 8, what we get is 16 minus 37, which is going to be negative 21 over 8. That's going to be my remainder, and this is going to be my quotient, and this is obviously the divider. So this is how you carry on the long division, long method division using the polynomial. I mean, for the polynomials.